Welcome to this explainer. Today, we are diving into the birth of the Himalayas. We're going to rewind deep, deep into Earth's history to witness, literally, the most spectacular geological collision our planet has ever seen. Which brings up a pretty massive question. How exactly do you build the biggest mountains on Earth? Well, to understand the mechanics of this giant construction project, we actually have to strip away all the snow, the ice, and the modern geography you're used to seeing. We are talking about tectonic forces that use the very crust of the Earth itself as building blocks. Because this is a transformation over millions of years. To really wrap our heads around it, we have to imagine a spectacular 3D timeline spanning tens of millions of years in deep time. We're zooming back to an era when shifting supercontinents and the ancient vast Tethys Sea completely dominated the planet. Driven by intense heat and churning magma deep inside the mantle, these giant continental landmasses were relentlessly drifting. So this wasn't some sudden explosion, right? It was a slow, completely unstoppable transformation on a global scale. And that sets the stage for our two massive heavyweight players, the Indian Plate versus the Eurasian Plate. Millions of years ago, the Indian Plate was actually situated thousands of miles to the south, but it was a total anomaly. It was sprinting northward at an absolute breakneck speed. Some estimates say up to 15 centimeters per year. Now, that might not sound like much to us, but in geological terms, that is exceptionally fast. And it was heading straight for a monumental, totally unavoidable crash with the giant Eurasian Plate waiting up north. Now, this whole monumental collision unfolded in three distinct steps. First, relentless movement. Second, oceanic crust subduction. And finally, landmass uplift. It all started with that Indian Plate relentlessly pushing north, slowly closing the gap across the ancient ocean that separated the two continents. That leads us right into the second step, which hinges on subduction. By definition, subduction is the process where oceanic crust dives or sinks beneath massive landmasses during a tectonic collision. And the sheer scale of the displaced material here was staggering. As India rammed northward, thousands of kilometers of ancient ocean floor simply had nowhere to go but down. Think of the oceanic crust like a giant conveyor belt, just getting dragged deep into the Earth's fiery mantle. It violently closed an entire ocean and pulled the continents of India and Eurasia closer and closer until, bam, they inevitably slammed into each other. Which brings us to a period of intense pressure and thrusting. See, when the continental crust of India finally hit the continental crust of Eurasia, neither plate could actually subduct. Continental crust is relatively low density and super buoyant, so it absolutely resists sinking into the mantle. So instead of diving down, these rotating, colliding 3D landmasses just ground together. The kinetic energy and the pressure were unimaginable. The solid rock was squeezed, shortened, thickened, and relentlessly thrust upward, violently transforming a once flat landscape into an incredibly turbulent geological zone. So let's look at the direct impact of the collision. It comes down to the subduction of the oceanic crust, massive landmass uplift, intense rock folding, and ultimately the creation of those iconic peaks and deep valleys. To put it simply, under all that extreme pressure, entire layers of the Earth's crust behaved like plastic. They were folding over one another, stacking up and thickening, kind of like an accordion. It was this profound deformation that physically births the mountains we know today. But violent tectonic uplift wasn't the end of the story. The Earth doesn't just build things up, it has other tools in its toolkit. As soon as these newly formed mountains pushed their way up into the atmosphere, another relentless natural force took over. Enter the final sculptor, erosion. You can think of tectonic forces as a giant bulldozer violently pushing the Earth upward, while erosion acts as this fine chisel, slowly and carefully carving out the intricate details. There's a great saying that erosion sculpted the Himalayan landscape into its current breathtaking form, and it is absolutely true. Picture those towering, folded rock layers thrusting into the sky. Now imagine elements like wind, freezing rain, and massive glacial rivers slowly carving through the mountainsides over millennia. They literally slice through the rising stone, deepening the valleys and creating those dramatic, jagged cliffs. The specific peaks we go out and explore today are just as much a product of erosion tearing the rock away as they are of tectonic plates pushing it up. And here is where it gets really crazy. This continuous geological transformation isn't just a closed chapter in a textbook. It's happening right now, right under our feet. The Indian Plate hasn't hit the brakes at all. It continues its relentless push northward into the Eurasian Plate to this very day. That means the Himalayas are still actively growing. In fact, they're being pushed higher by about 5 millimeters a year. To put that into perspective, that's roughly the same speed at which your fingernails grow. So this epic tectonic crash is very much an ongoing event. Since this epic collision is still playing out in slow motion, it leaves us with one final, awe-inspiring question. What will the Himalayas look like millions of years from now? If the Indian Plate keeps up its relentless march, will these peaks grow even higher, pushing right into the stratosphere? Or will the relentless forces of erosion eventually catch up and carve them down faster than they can rise? It's an incredible thought experiment, and it really reminds us that our Earth is a dynamic, ever-changing masterpiece, and we are just lucky enough to be here for a tiny, fleeting snapshot of it. Thank you so much for joining me for this explainer, and I'll see you next time as we unpack another fascinating topic.